is just an equation that graphs a straight line, which everything you've seen right now has been straight lines. So it seems like that's all we know, so it's not everything. But if we think about the conjugate, we're just having calculus increases saying like, what about the curvy ones? There are a couple different types of graphs. When you get to algebra 2, you're going to study kind of every single type of function there are. Your basic algebra 1 type is a linear function, which is just a straight line. You can write functions. Function and equation just means the same thing in different forms. Like I said, today we're just talking about standard form. Standard form is all of your variables on one side, your constants on the other. So algebraically, it's that form of ax plus by equals c. There's a lot of letters there. So really all it means, your x's and y's are on one side, your constant term is on the right. You don't have to have an x and a y term. You can have just an x, just a y. Why? Let me look, Caitlin. So once you finish copying that in, it says, what can we do now? So that's a review of what we did last week. So try to see if you can answer that. It says, Kevin can run 3 miles in 24 minutes. Find your constant of proportionality, explains what it means, write an equation, try to draw the graph. That's something that we should be okay with doing right now. I'm going to look in Caitlin and see if you don't have this. Caitlin, you should. It should say Tuesday the 17th, graphing lines. Refresh your Google Classroom. It should be right in there. It says period 7, November 17th, Tuesday, linear equations in standard form. It says it's assigned to everybody. So it should be in there. You might just have to refresh your Google Classroom. Okay, so everything we should know how to do. Take a simple sentence like that, find the slope, find the rate of change, draw the graph. If we just think about a table. So we're comparing miles to minutes. So I put minutes in your X column, so let's put minutes here, let's put miles here. Write in what we know. In 24 minutes, he goes 3 miles. So we could plot that coordinate point, something we should be able to know how to do. Come over to, let's back these up. These aren't right. Let's change this to miles. Let's change this to minutes, because that doesn't make any sense. Flip-flop. So then let's flip-flop this. Just because the scaling is better. So let's go miles to minutes. So in 3 miles for 24 minutes. So again, plotting that should be easy. We should know how to do that. Miles is on the X, so we should be able to come over to 3 miles all the way up to 24 minutes and plot your point. Should be able to find your constant of proportionality, or how many minutes per mile. So how many minutes per mile does he go?
That's 8.
Right. Because what we talked about last week is that if it's just a constant linear function, y divided by x, 24 divided by 3, gives you your constant of proportionality. That's your slope. So we rewrite it as 8 over 1. We should be able to make another point, right? From here, my slope is 8 over 1. I can go up 8 and over 1. I'm counting by 2's here, so 2, 4, 6, 8. Goes about here and over 1. So you should know how to kind of move with your slope. We should also be able to recognize that the constant of proportionality scales everything down to 1. So when we find that, it means it takes him 8 minutes to run 1 mile. So we should be able to also plot that. We should be able to know that your line makes a straight line. I graphed that really goofy, it doesn't fit. Forms your straight line through. You should be comfortable knowing that the slope shows up at that first point, 1 comma k. You can find your slope by dividing any coordinate point, 8 divided by 1, 24 divided by 3. It's all stuff that we want to be comfortable doing. Looking at standard form, we're getting into a different way to graph. So right now we should be okay with knowing how to graph using a slope. Top number tells you the vertical change, bottom number tells you the horizontal change. We're gonna get into a conversation about x and y intercepts. Have you heard those words before?
Yeah.
Okay, so we're gonna get into a conversation about that and how we can graph something based off of x and y intercepts. This is just graphing something based on the slope. So we have another problem. It says at the beginning of the year, Kevin had $900 in his bank account. At the end of January, he had $750 in his bank account. Assuming that he spends the same amount of money each month, this is like typo there, because I'm talking about months in the table. So each month, complete the table and graph to model this scenario. So at time 0, so January 1st, how much money does he have? $900. The end of the month, February 1st, $750. So we can plot those 2 points. Time is on the x, money is on the y. So 0 to 900 would be here. We're counting by 100s. 1 month, 750 is about here. Still want to fill in the rest of the table. So if we need to fill in the rest of the table, we just need to figure out what your rate of change is. So try to see if you can figure out how much money is going to be in his account after 2 months and after 3 months. I want to try and see if I can fix this for her. Caitlin. So you might have to refresh again. I'm sending it just to you, Caitlin. If anybody else is having trouble, I don't know that unless you channel me.
It says $10,000 instead of
Sorry, that should say 1,000. Good call. That's 1,000. Just back down here. Okay. So so what are we? So come March 1st, we need to figure out how much money we're losing each month. So you can find your slope. We learned how to find the slope by subtracting 2 y values and subtracting 2 x values. So if I find my slope here, this coordinate point is like your x2, y2, x1, y1. So if I use slope formula, we can subtract our 2 y values and subtract our 2 x values, and it's going to tell us the rate of change in the slope of the graph. So what's 750 minus 900? Negative 150. 1 minus 0 is 1. So that's our rate of change. We're losing $150 per month. So then by month 2, if I take 150 away from 750, where are we? Okay.
600.
600. If I take 150 away from 600.
150.
Right. So now we can fill in the rest of our table. We could have also, or the graph, we could also use our slope to draw the graph. If my slope is negative 150 over 1, I can come down 150 and over 1. Down 150 and over 1. Down 150 and over 1. Or you can just keep plotting your points, but you're going to notice you get the same thing. So month 3, we're at 400, and we keep coming down. So we're going to come down here. Make sure you can see these 2 points on the x-axis and the y-axis. Okay. The next question says, what does the coordinate 0, 900 mean? So here's my coordinate 0, 900. In terms of the problem, what does that coordinate mean? Or what does that information tell us? Okay.
It's supposed to be well, it doesn't change it. It tells you that he had $900 at the beginning of January.
Right. So at the beginning of the year, or at the beginning, he has $900. That point where your graph crosses the y-axis is known as your y-intercept. Where does your graph intersect your y-axis? At your y-intercept, your x value is always 0. What is the value of x when y is 0? So now if we come down and look at our graph, when y is 0, what is our x value?
6.
6. So when y equals 0, x equals 6. So if we write that as a coordinate point, we have 6, 0. What does that point tell us about the problem?
When it was 6 months, we had $0.
Right. By month 6 or by June or at the end of 6 months, he has no money. So he has to figure out a better way to budget, basically. Okay? That's your x-intercept. That point where your graph crosses the x-axis, where your y value is 0, is known as your x-intercept. So the next way we're going to talk about graphing, we're not going to worry about finding all of these different points. If we can easily find the y-intercept and easily find the x-intercept, plot both of the points, and then you just have to connect your 2 dots. They're easy points to find because in your y-intercept, your x value is always 0. In your y-intercept, your x value is always 0. Okay? Go with that. I don't want to do this problem. I'd rather finish up and then give you time to work on your other homeworks. Okay, so it says an amusement park charges $22 for an adult ticket. So those of you at home, I skipped the third one. I'm moving into question 4. So they charge $22 for an adult ticket and $12 for a child's ticket. They expect to make $30,000 on opening day. Write an equation to show how many adult tickets and how many child tickets they need to sell. So I want you to use X. I want you to represent as the adult ticket. And then Y is your child ticket. So step 1, try to read through the problem again and see if you know how to write the equation for it. So they charge $22 for an adult ticket, $12 for a child ticket, and they expect to make $30,000. Oh yeah, does anybody else want to calculate it? Anybody? So see if you can just write your equation. What would it look like? How would you show how many adult and child tickets they can buy? And then if you get your equation, you can draw in your x and y axis like I did. For some reason, I just forgot to write that on your copies. If you feel stuck in your equation and you don't really know how to write it, you can still draw that in. But we are going to end up graphing it. So to help you with your equation, you have a total on one side equaling the information about your adult tickets and your information about the child tickets. So once you get your equation, you don't have to worry about anything else. You don't have to worry about solving anything. Just draw in your x and y axis. Then we're going to go through how to graph it using an x-intercept and a y-intercept. So when you're doing your equation, you don't have to do any math. You don't have to divide anything. You don't have to find any calculation. You're just taking the information from the problem and translating the paragraph into a number sentence. So in terms of words, it pretty much looks like this, like I said. What is the total that we know?
30,000.
$30,000. So we're using that. Equal to, what do I know about the adult tickets?
They're $22.
They're $22 for an adult ticket. So I charge $22. Do we know how many we sell? Not yet. What letter do we use to represent the adult tickets? X. I have to figure out the information about the child ticket. How much is each child ticket?
$12.
$12. I don't know how many I bought yet. I'm using Y to represent that. So that's your equation. You don't have to calculate anything yet. You don't have to solve the problem. You're just taking those words and translating it into a number sentence. So we did the first part, write an equation. Check. Graph the equation by finding your x and y intercepts. Okay? So as a side note, your x-intercept always shows up when y equals 0. So your x-intercept is one of the easiest points to find because your y value is always 0. Your y-intercept is your second easiest point to find because x is always 0. So we're going to take this equation. We need to figure out what the x-intercept is and what the y-intercept is. And we're using the knowledge here that for your x-intercept, y is 0. Because I'm crossing the x-axis here, so my y value is 0. So if this is my equation, and my x-intercept, y always has to be 0, so we can plug a 0 in. And say 22x plus 12 times 0. Finding my x-intercept by plugging 0 in for y. Why does that make things easy? Why do I want to try to plug zeros into things?
Because it makes it 30,000 equals 22x.
Right. Because mathematically, when I multiply, what is that? Mathematically, when I multiply anything by 0, it cancels out. So knowledge of the x and y intercepts we like because basically if I'm looking for my x-intercept, I can just ignore the entire y term. Because if y is 0, 12 times 0 just cancels out. So like she's saying, it just turns into your equation, 30,000 is equal to 22x. So then how do you solve that for x? And how do you figure out what that x value is? Yeah.
We divide 22.
Do 30,000 divided by 22. And what do we get? $30,000 divided by 22. Fine. Okay, so we're getting a decimal. We have our scale here, so we're going to estimate things. So let's just ignore the decimals. So what would you round your number up to? Right, 1,364. So when y was 0, our x coordinate is 1364. So now we can plot that point, right? My x value is 1364, and my y value is 0. So here are my values here. We can count this in terms of hundreds, 200, 400, 600, 8, 10, keep going. So if I'm plotting 1364, it's going to come somewhere in between 12 and 14. So I'm just going to plot the point. Now we want to find the y-intercept. Again, we like to find the y-intercept because it's basically the same thing. It's a point on this line. X is always 0 here. And it's going to work out the same way. If I plug in a 0 and do 30,000 times 22 times 0, the reason I plug 0 in is because it just cancels out. I don't even have to worry about it. So when you're finding your y-intercept, your whole x term cancels out and goes away. So then what does your equation turn into? You drop that whole middle part out because 22 times 0 goes away. You get 30,000 equal to 12y. Because 22 times 0 cancels out. So then what's your y value? If x is 0. Okay,
2,500.
2,500. So then we can plot that. Again, in terms of hundreds, 400, 800, 1,200, I'm looking for 2,500. It's going to come somewhere in between 24 and 28, a little bit below the midline. So now that we found 2 points, all we have to do in order to graph it is, as best we can, just connect them into a straight line. That way we don't have to worry about finding this stuff. All of your information is in there. This problem seems complicated because the numbers are so big and so funky. But the basis of it is that we like finding those 2 points because in your y-intercept, you just ignore the entire x term in the equation because x is 0 there. In your x-intercept, y is 0, so you can drop the whole y term. It becomes a lot simpler than what I said this looks like because we have all of those thousands and they're really big numbers. Next 2 examples we're going to look through are just very straightforward. Find your x and y intercepts with smaller numbers. You'll start to see the simplicity in it. But do we feel okay with that? So now if we look at question 5, we have a lot easier numbers. We're going to graph each equation on the same grid. So we're going to make little codes. We're going to do A in a straight line. We'll do a dotted line for B. And then, I don't know, like a pointed line with points for C. Unless you have different colors you can use. But you just want to be able to see the difference because we're graphing them all on the same graph. We're using x and y intercepts. Again, we like them because in your x-intercept, we'll go that way first. So in your x-intercept, your x-intercept falls along the x-axis. Y is always 0 there. So when you're looking for your x-axis, if I plug in a 0 for y, what's 4 times 0? Okay, 0. So the whole thing goes away. So we don't even have to worry about it. So when I'm looking for the x-intercept, we have 2x equals 16. So what's your x value have to be? 8. So that means your x-intercept is the coordinate point 8, 0. Draw it in on your graph. So when I plot that, I have 1, 2, 3, 4, 5, 6, 7, 8, 0. Then you look for the y-intercept. Again, we like it because it falls somewhere here. X is always 0 here. So if I plug in a 0, 2 times 0 just goes away. So then I can just ignore it. So then my equation just turns into 4y equals 16. Again, it becomes very quick and easy to solve. What does your y value have to be? Carolyn? 4. So that's your coordinate point. When x is 0, y is 4. So 0, 1, 2, 3, 4. You come through, and you connect them. It's very easy. It's very easy to do the math in your head. Try to do B and C. Part C is not written in standard form. So you can see a difference. Standard form is when your x's and y's are on the same side. This is not written in standard form. You should still be able to do it though. Again, key is that for your x-intercept, y equals 0. For your y-intercept, x equals 0. So in standard form, we can kind of just ignore the terms, but you might get a little bit confused if you try to do that. You're looking for your x-intercept or your y-intercept? So your x-intercept, the y can move away. So then you have negative x is equal to 3. So you want to know what positive x is. So negative x equals 3. Positive x equals what? negative x equals 3. You want to know what positive x is. So negative x equals 3, positive x equals 1. So your x intercept is here somewhere. Your y value is 0. So you can just ignore the y. So then rewrite your equation, ignore the y. You always want to know positive. So negative x, negative, that's right. The next step just then is if negative x equals 3, what does positive x equal? Can you graph them? You want to John graphs? Okay. Because you're dividing by 2. 3 divided by 2 is 1. Not 1/3. Then you got confused with the 2's and 3's. Let me show you more. So that if it's a very automatically, then it's weird. So your coordinate point, x is -3, y is 0. So you say -0, and we'll just start with that. And then you find your y-intercept. So we'll go over B, because we seem to be okay. Some of us got a little stumped with the first part. We knew what to do, so we got this far. And we said, well, y is 0, so let's ignore that. And we just end up here. But then we get a little bit confused because there's no number there. But if it's negative x, technically what number is in front of the x? Sign? It's like a -1. So you can even really think about this as dividing by -1. So you get x is equal to -3. So that's your coordinate point. -3, 0. Plot that, 1, 2, 3 goes here. Second one, find your y-intercept. Means x cancels out. And then some of us just got a little confused with the division. We're dividing by 2. So y is 1.5. So your coordinate is 0, 1.5. So 0, 1.5, and connect them. We go to a C. It's written different, so you're where you're solving it. When you're graphing, make sure your lines are going through the whole thing. I see a lot of you kind of just connecting the points, which is okay. More so in contextual problems, we just do that like with the ticket problem. It didn't make sense to extend a line because we wouldn't sell a negative number of tickets. We might have a negative amount of money if we're in debt. So we kind of just stop at the points. But if it's just something like this, you want to see the whole thing. So this is basically 1,300. You can ignore this because the scale is not going to be precise. So 1,300 just to finish up with part C, so that way you can get started on your homework. Finding your x-intercept. It's written different, so it's not as easy as just ignoring the term. Because if I just ignore the y term here, it seems like there's nothing there. So that's where you really want to understand that it means you're plugging in 0. So if I plug in a 0 here, we get -x minus 5. So then you're just trying to solve it for x. So what would your first step be to solve it for x? I don't want to make x positive yet. You're going to have to, but it's going to become more complicated. Grace? Add 5 to both sides. And we get 5 is equal to -x. Again, kind of looks like the same one here. We always want to know what positive x is. So then what's my answer? Grace? -5. So come over to -5 on your x-axis. 1, 2, 3, 4, 5. Then you find your y-intercept. Find your y-intercept. putting a 0 in here, that's gonna cancel out. So that ends up turning out really nice. We can already see what our answer is. Y is equal to -5. If we back up, -0 minus 5. -0 is not even a thing, it's just 0. 0 minus 5 is -5. So then 1, 2, 3, 4, 5. What about that? Okay, for your homework, it's attached. They're not scaled, right? Like there's not an X and Y axis. Okay, let me help you. Where's my mouse? I'll erase the answers. I guess you don't really. So when you're graphing these, you can count everything by ones. You don't have to write in the scales and like label everything. You can just count and plot like over 2 up, whatever you need to do. The only one that's going to cause you issues is the first one. For your x-axis, you should count by 2s because it's not going to fit. You're going to start seeing that. So for your x-axis, you can count by 2s here. Everything else, you're going to be able to just count by 1s to plot. Put a big grid in the middle. You're going to have to draw that part in. You don't have to label them all. You don't have to put the numbers in. You can just count the blocks. I don't want to erase all that because I don't want to redo that. We should be good. So then those of you at home, you can stay in here. There's 7 minutes. You can work on your homework in here if you have questions, or you can sign out. This should be like the next section. Well, it jumps to chapter 4. We kind of jump around all around. But so this was standard form. Tomorrow you're going to do slope intercept form.